Today, we're diving into Kubernetes stateful sets. These are the specialized tools you need for those supercritical applications that just can't afford to lose their identity or their data. So yeah, if you've ever been a little nervous about running a database in Kubernetes, this one's for you.
Okay, so to really get why stateful sets are so important, we have to start with a core question that pretty much frames all of modern infrastructure. How in the world do you manage pets in a world that's built for cattle? So on one hand, you've got cattle. Think of your web servers or your API gateways. They're totally anonymous, completely interchangeable, and if one of them goes down, who cares? You just replace it with an identical clone. But then you have pets. These are your databases, your message queues. Every single one is unique. It has a specific name, a history. You can't just replace database primary with some random clone, right? It needs its specific data and consistent care. Now, this is where the problem starts. Your standard Kubernetes deployments, they are absolute masters of the cattle model. They are built from the ground up for stateless applications that can be created and destroyed without a second thought. And that creates a real challenge when your most critical applications are, well, stateful pets.
And look, we're not talking about some minor apps here. We are talking about the absolute backbone of your services. Things like your PostgreSQL or MySQL databases, your MongoDB clusters, your Kafka message brokers. These systems are your source of truth, and you just can't treat them as disposable.
And this is exactly where the stateful set comes into the picture. It's a specialized Kubernetes controller that makes a series of non-negotiable promises, or guarantees, to your stateful applications, which allows them to really thrive in this containerized world.
Okay, promise number one is a stable network identity. Unlike a deployment, which gives pods these random, disposable names, a stateful set assigns a persistent, ordered name like app0, app1, and app2. This gets paired with a special headless service, which is cool because, unlike a regular service, it doesn't load balance. Instead, it gives each and every pod its own unique, predictable DNS address. This is absolutely crucial for clustered systems, where Mongo 0 has to be able to reliably find and talk to Mongo 1.
Promise number two, stable storage. And this is a brilliant way to understand the concept of data gravity. A stateful set uses a template to create a unique, persistent volume for each pod. So the data for app 0 is forever tied to app 0. If that pod crashes and gets rescheduled to a completely different node, Kubernetes makes sure it reconnects to its original storage volume, preserving its state perfectly. So you might be asking, how do stateful sets actually pull all this off? It isn't magic. It all comes down to a strict, predictable, and ordered sequence of operations for pretty much every single thing they do. So check this out. When you scale up a stateful set, the pods are created one by one in a super strict sequence. The controller will create pod 0, and then it waits. It waits until it is fully running and ready before it even thinks about creating pod 1. Without this, you just have chaos, right? You'd have replica nodes trying to connect to a primary that isn't ready, which can lead to all sorts of failures. This ordered startup is what lets a cluster initialize gracefully. And scaling down is just as deliberate, but in perfect reverse order. The pod with the highest number, let's say pod 2, is terminated first. The system waits for it to shut down completely before it moves on to pod 1. This is so important because it allows a cluster to safely drain connections and replicate data to the remaining members before a node is just yanked out of service. Okay, so that's the theory. But what does this mean for you in the real world? Let's talk about day-to-day stuff, like updates, and a really critical built-in safety mechanism that you absolutely need to know about. You have very precise control over how updates happen. By default, you get a rolling update strategy, which updates your pods in that same careful, reverse-ordered way, from the highest number down to the lowest. This is perfect for zero-downtime database upgrades. Or you can choose the on-delete strategy, which gives you full manual control. The new version only gets applied when you personally go in and delete an old pod. And you can get even fancier. You can actually perform canary releases. By setting an update partition, you can tell the stateful set, hey, only update this single pod, say the highest numbered one. This lets you test the new version in production on a less critical replica before you commit to rolling it out across the entire cluster. It's a really powerful feature. But with all this power and predictability comes a really critical responsibility. The way stateful sets handle failure is unique, and it's designed to protect your data above all else. So, what happens if a node just disappears off the network? Kubernetes can't be sure if that node is really dead or if it's just temporarily disconnected. To prevent a catastrophic split-brain scenario, where you could end up with two instances of DB0 both trying to write to the same data and corrupting everything, Kubernetes will not act automatically. That pod will just be stuck until a human operator, you, investigates, confirms the node is gone, and then manually force deletes the pod. It's a deliberate choice. Data consistency is prioritized over automatic recovery every single time.
Okay, so with all that in mind, let's put the two main controllers head-to-head. This should make the choice of when to use each one crystal clear.
So here's the bottom line. A deployment is built for your stateless cattle. The pods are ephemeral and interchangeable, and they all share a single service endpoint. A stateful set, on the other hand, is the specialized tool for your stateful pets. Here, every pod has a stable identity, its own unique network address, and its own dedicated storage, and it's all managed through that ordered and predictable lifecycle.
And this brings us to our final thought. Stateful sets offer incredible power for running really complex distributed systems on Kubernetes, but they also demand a much more deliberate approach to how you manage things. So now that you understand the guarantees, the ordered lifecycle, and the trade-offs, you can decide if this powerful tool is the right foundation for your most important applications.